do slope and constant variation, we have to understand that they are the same thing. And since they're the same thing, all we have to do is find it, and we know what the slope is. So here's this direct variation formula, which the -4 is the slope. So let's prove that. If I take 4 minus 0, that's my y change, and then I go -4 minus 0, I get 4 and -1, which is -4. But if you look right here, it's also given. So our direct variation and slope is the exact same thing. So our answer in this case is -4. So let's look at our other problem. We have a direct variation of 1/2, so our slope is the same exact thing. So these two are the same idea. So if we understand that direct variation and slope are the same thing, all we have to know is where we start our graph. So if we look at our graph, when there's no intercept given, our graph starts on 0. And now we know our slope is -1 over 1. So we can go down 6, 1, 2, 3, 4, 5, 6, and to the right 1. And we can connect those two dots, which my dots didn't connect very well, so let's get them. There we go. And we have our graph. When we're solving a direct variation, we want to set up with a direct variation equation. And we fill in the blanks. So we have y is 72, so I'm going to put a 72 for the y, and we have x being 8. And so we have k, which we don't know. So if we divide both sides by that 8, which solves k for us, we get direct variation of 9. Now if we know that the direct variation is 9, now that we know the direct variation, we can solve by putting in when y equals 63, and we know the direct variation is 9, we want to know what x is. So now we have 9x, so if we divide by 9, we would get x equals 6. So we can find x, we can find y, or in this case we can find k by just using this formula for direct variation.